All right, we spent the last clip evaluating a bunch of square roots and cube roots. Remember, recognition of the perfect squares, perfect cubes will help speed things up. You're going to be able to use your calculator. An indication that it's going to be calculator work is if it says round to so many decimal places. If it says that, then do so accordingly. When you look back at that clip, you're going to see that we had the cube root of 8 and then we had the cube root of negative 8. We had an answer of 2 and negative 2 respectively. Well, there's a reason why that takes place. And in the rewrite, when I rewrote the 8, or I rewrote the negative 8, the reason I was working towards that is because we've got a kind of a basic definition that we'll utilize for simplifying. Okay? This is a generic. This is the nth root of a to the n. Okay? As I took those and rewrite, if you watch back, after you watch this clip, go back to the last one, you'll see that these numbers, as I rewrote that 8 into 2 cubed and that negative 8 into the quantity of negative 2 cubed, I got to the point where these were the same value. Okay? Well, as you go through, what we saw was that if these matched, we just took out the base. Okay? So there's a phrase that I utilize. If the power and the index match, take out the base. If the power and the index match, take out the base from the radical. Okay, that's a basic idea of simplifying. Okay, when we see this, if the power and the index match, basically they cancel each other out and we take out the base. This is for odd indexes. So when that is a 3, a 5, 7, a 9, anytime it's an odd index and those match, we just take out whatever the base is. That will allow it to be a positive or negative depending on what we have. Okay? We also have another one. We will still utilize that phrase. If the power and the index match, take out the base. Now, if that's an even index, what you're going to see is that it's going to be similar. We saw the square root of 36. We wrote it, and that we said that the answer was 6. Well, let's remind you of that. We had the square root of 36, correct? And we rewrote it like this. Well, we are remembering that that's a 2. Power matches the index, we take out the base. Well, here's the thing about a positive number. There are 2 ways to get to a positive number. There's 6 times 6, positive times positive, but there's also the possibility of negative times negative. So I could also have it rewritten like this. Negative 6 quantity squared, well, that's negative 6 times negative 6. That negative times negative becomes positive. But when you go through and you plug this into your calculator, it does give you the 2 options for the answer. It only gives you one answer. Okay? So as you go through, well, why does that work? Well, in many instances, we want to rely on values that we can use. Even though it mathematically works and makes sense, it may not make sense in the context of what we're doing. Okay? So what we will see is that we have an understanding of that. So to ensure that we're going to have something that we can utilize, most often the positive, what we do is this has an absolute value around it. So if this is an even index, if the power matches the index, and we look to take out the base, we take out that base and make sure we have an absolute value around it to apply that to ensure that it's going to be positive. So if you plug in this into your calculator, it'll give you the 6, but there's this option here. Well, if I take and apply the absolute value to that, then I get my positive. Okay. We want to know that later on that there's a possibility of those 2 solutions, but main thing to remember, if the power matches the index, take out the base. If it's an odd index, this will be the sign of whatever the radicand was. If it's an even index, power matches the index, we take out the base and we ensure that it's going to be positive. Okay? So, when we go through this, what if I have something like this? So we're going to start adding in the variables here. We don't know what they are, but it's going to, when we do this, we're going to really rely on this. Okay, getting away for where we don't want to plug have the ability to plug in the calculator. I don't want to plug this into the calculator because I don't know what y is stored in your calculator. It'll be different for each person. So this is just really going back to these definitions. Well, we understand that this is a square root, so we know this is a 2. So we will have to apply this. The power matches the index. We're going to take out the base, so the base is going to be y. And remember, the context of what we're dealing with. I don't know what the value for y is yet, but under most circumstances, we're going to want to make sure that it's going to be positive. To do that, I have to apply the absolute value. So then when you plug that y in, whether it's positive or negative, it will come out to be positive overall. Okay? What about cubed root of 125 x cubed? Okay, well that power already matches the index, so I know I'm going to be able to take out the x. 125, I'm going to have to think about. If it ends in 5 or 0, there's probably there's a 5 in it. Well, that's more likely, really, could be written as 5 cubed x cubed. 5 times 5 is 25 times 5 is 125. If the power matches the index, take out the base. Now, whether I apply an absolute value or not depends on if it is an odd index or not. Odd or even. Well, 3 is odd. So I do not need an absolute value. If I apply an absolute value to an odd index, I'm limiting what it could be. Power matches the index, take out the 5. Power matches the index, take out the x. I will not need an absolute value with an odd index. Okay? So, in the next clip, we'll do some more of these and then have your you try problems. I know I said it in the last one, but it will be on the next one.